Okay, so the distance formula looks like this. D, and for the freshmen, actually, everyone was here on Tuesday, so that's for an E period. Yeah.
Are you sure we are?
No. You guys were here Tuesday last week. This week. You weren't here yesterday. No. Well, I know you guys were always out Tuesday. Hey, boys, guys, thank you. All right, so and let me actually move closer to the center. Okay. Oh, sorry about your back. Okay, so let's talk about this here. Okay, so that's the distance formula. It's pretty straightforward in the sense that x2 and x1 are 2x coordinates, y2 y1 are y coordinates. You throw it in, work out the math, you get an answer, right? A lot of times people just look at it blindly and don't really understand what the heck it's doing. What is it doing? It's taking 2 points, say call this x1, say call this x2, and y1 and y2. Peter, you have a question?
Oh wait, I was gonna tell you what it does.
Yeah, what does it do?
So basically, it gets the distances of the two x's and the two y's.
Correct.
So then when you do it, then you can find like the full distance.
Right. So what it's doing, actually, what the one thing you're missing that's very important, it's doing Pythagorean theorem.
Oh yeah.
That's what it's doing. Like if I call this A, call this B, call this C, we know A squared plus B squared equals C squared. We've established that already, right? So we build on that. A is clearly the difference of those x coordinates. B is clearly the difference of those y coordinates. So if you take those differences, x2 minus x1, y2 minus y1, and substitute for A and B, so this right here is A. This right here is B. And C is the square root of all that junk. C being the hypotenuse. And the hypotenuse so happens to be the distance between the 2 points. So now I know the distance between the 2 points is C. So for number 1, I don't have to plug those numbers into the formula. I could just say, well, what's the difference between 3 and -4? 7. What's the difference between 7 and -1? 8. Work it out. I get 49 plus 64. What does that add up to? 113. And that's how I get the answer. You never, ever have to use that formula. This is especially true for those who are sophomores doing SATs next year as juniors, or the freshmen doing SATs in a couple of years. They'll ask that kind of question. They'll expect you to know that. And people like totally mess it up. Like, well, I don't have this before, I can't do it. But yes, you totally can do it. Just, Pythagorean theorem. You've known it for a long time. That's all it ever is. It's just Pythagorean theorem. Now, if you want to plug in the formula, go for it. Great. If you want to do that, then great. I could do square root of 7 minus -1 squared plus 3 minus -4 squared and work all that math. You can. They'll still get you the same result. For number 1, it's the first x coordinates. It's the x coordinates, right? No, I'm doing number 1. Sorry. So let's try another one. Let's do 9 was next. Okay. Okay, stop the noise for the thanks, appreciate it. Okay. So for 9, I'm going to start using Pythagorean theorem, right? Like, yeah, I'm just going to do a quick sketch of the coordinate system. So you have that -6, -8. So I can kind of ballpark it a little bit. I'm not going to really do all these tick marks just in the interest of time. But what we could do, if you guys find it helpful, we could provide you a coordinate plane. Would that help you guys if I provide a coordinate plane for problem? Like, yeah, I can do that. It's easy. It's not hard. Just copy and paste from a previous test. All right. Then what you do is you draw a right triangle around it. Now, let me ask this question. How long is that horizontal leg? How long is the base? Good, because you're going from -6 to -2. How long? What's the height? From what to what? Perfect. See, by labeling it, it's very obvious what's happening. So if this is, we call this C or D, whatever you want to call it, I don't care. D is going to equal the square root of 16 plus 100. Why am I square rooting? Because D squared equal 4 squared plus 10 squared. In order to get rid of the square on the D, you got square roots. So you get 116. Now, the one thing we will ask you guys is to not leave your answer like that. Like you still have to take it a step further. Simplifying radicals. Why we did that in the previous 2 units. How do I simplify that? You'll have a calculator. You can use any calculator, not a problem. If you like the graphic calculator, it has a nice interface. It's big screen. That's all good. If you just divide that by a bunch of numbers that are perfect squares, like 4 is a good one to divide by because 4 is a perfect square. You could try 9, you could try 16, whatever. But if you do that, you should get 29. So it means that root 116 is root 4 times root 29. You can break it off like that. And what's root 4? That's to get 2 root 29. So every single problem in the homework that we assigned, there's only 8 problems we assigned here, would work that way. So those other ones we didn't assign, you could do that for practice next week or over the weekend if you feel like you need more practice to this. But yeah. And maybe I might make one of the answers root 67. Okay. Yeah, we're gonna keep doing it so you guys get sick of it. So all right. Okay. Anyhow, yeah. You do, yes. Oh, point. Yeah, point. But just do it. Now you know. Just do it. I'll tell you too. All right. So now let's move on to the notes, guys. I think we're good on the homework. We want to, oh, okay, let's do one. Sorry, you want us 27? Okay, sorry. I should have asked. My apologies. Okay. All right. Actually, those are great. Okay. I'll tell you right now, those are a little too challenging. Won't quite see something like this on the test because you guys are still trying to get used to this. And plus, you'll do more radical stuff in algebra 2. But nonetheless, we should talk about it. What makes it challenging is combining the radicals, which you guys have not had enough practice doing. I get that. So if you think about it, I'm still going to do the same thing. I'm not going to change my ways. Negative root 2, which is somewhere over here. Negative root 2, somewhere over here. I'm not going to change my ways. I'm still going to do it the same way. Root 2 I know is positive. So somewhere positive for root 2 and 6 root 2. This is where it gets challenging, is to subtract the coordinates, right? So you got these 2 dots, you connect them, lovely. You draw a right triangle, that's awesome, right? We got this. Here's the challenge. How long is that base? The base is going from negative root 2 to positive root 2. So you're subtracting those 2, right? Like when we went from like negative 2 to negative 6, I know the difference is 4, right? If I'm doing root 2 minus negative root 2, what would you say that would be? Yeah, because the minus negative becomes a positive. And how many root 2s do I got? I got root 2 and another root 2. It's actually 2 root 2. It's kind of like saying, what if I had x plus x? What would you say if you had x plus x? It's no different. It's the same exact thing. Looks good. Sure, yeah. It's the same exact thing. So now, what if I have 6 root 2 minus negative root 2? Positive, positive. 7 root 2, good. So now I know the height. Sure, yeah. Yeah. Yeah, it's just like what? Yeah, because like what if I had x plus 3x? 1x plus 3x. Same thing, right? Then if I do Pythagorean theorem, a squared plus b squared equals c squared, or d squared, whatever you want to call it. And that's 2 squared. That's 4 times 2 plus 49 times 2. Work it all out, you should get 106. And then square it afterwards. 28 works the same exact way. It's the same thing. Okay. So does that make sense, Kira? Yeah, cool. Yeah, that's what we do. So, but we're not gonna do it quite that challenging because we haven't had enough practice of combining radicals. I think a problem more like the first page is more reasonable. So, and Mr. Davis and I are ready to start talking about the test. We have a general idea of what we want to do. We haven't finalized it. We'll finalize it probably by tomorrow afternoon. And we'll let you guys know by Monday what to expect. So, okay, let's go to our notes. I really want to finish off the unit. And by the way, I'll do you guys a solid. No homework this weekend. Enjoy the weekend. I know it's like a lot of people are celebrating Halloween this weekend, you know, so those parties and whatnot. I know, but
Yeah.
but still people will celebrate this weekend. You know,
I'm just.
yeah.
I can't imagine.
But you can get a head start the test if you want to prepare. You can. Okay. So everyone's got their notes. I have extra copies. If anyone's missing this page. I'm just gonna pack. Everyone's got their notes. Okay. So last part, 3.2.6 near the end. Applying similarity. Let's recap what we did last time. How long is let me get a highlighter here. Highlighter's good. How long is that side? That's in green. Good. The 16, that's right. So that's 16. Because 16 plus 4 obviously gets me 20. We'll call this h my height. Okay, this is what we did last week. And we kind of recapped it on Monday. How are all those related? Go, Faith.
Like ratio, you can.
Go ahead. Tell me. Sure. Go ahead. Perfect. Exactly. This is what's happening, guys. H equals root 16. So whenever you have a situation like this here, a right triangle and an altitude within that right triangle, you got two sides split, 20 split into 16 and 4, and you have the height. The height's always going to equal the square root of 16 times 4. Why does that make sense? Because 16 over h, the long leg divided by the short leg of the triangle off to the left, is in the same ratio as the long leg over the short leg for the little triangle off to the right. Why? Because they're similar triangles. You can prove if you want to by making up values for the angles in the triangle, and you would see for yourself, oh yeah, they're similar triangles. When you cross multiply, you get this. And to get h by itself, you got a square root, leading you to this. But you can short circuit the whole process by just going straight to the square root and say, hey, that height is a square root of 16 times 4. That's called the geometric mean. And that's how you can get to the answer quickly. Now, of course, what does h equal? Yeah, h is going to equal 8. Now that I have that figured out, now I know h is 8. How do I get x and y? What would I do? Pythag. Yes, thank you, Faith. We got Pythag it. So now I know, hey, 8 and 16. And y. 4 and 8. And x. Go and work those out. Tell me what you get for x and y. And share with your table group. Ugh, what's that going to be? Hopefully you guys get those answers. 16 is 196. 64 is 8 squared 64. You should get 260. 4 is a factor, 260. Breaks it down that way. And then the other one, am I could be wrong. Oh, you know what? I made a mistake. 16 squared is not 196. I did 14 squared. I made a mistake. Thank you for correcting me, guys. Good. I didn't do it on purpose. I totally made that. Totally did that for real. So 256. See, I'm human. I make mistakes. And right, 60 can be pulled out of it. Actually, 64 can be pulled out of it. Yeah, it's 8 √5. Yeah, because 64 can be pulled out to 320. Yeah, overall, that makes sense now. Yep. Yep, that makes sense because it will also fall Pythagorean theorem for the overall triangle. Okay. So that's something that I don't know if we'll quite do it that challenging on the test because there's quite a lot going on there, but you need to be aware of the geometric mean. Okay, let's move on. As you can tell, this worksheet's all about word problems and a proof at the end. There will be a word problem on the test. There will be a proof on the test. And these are big ticket items. So you need some time to absorb it. And I'll still give you the review packet. So if you want to do these problems in the review packet, that's a good idea. Also this weekend, we got the play. I forgot to mention that. So yes, go watch play too. So that's why I'm not assigning homework. Tonight, tomorrow, and Saturday. Oh, wow. 4 days? Crazy. Oh my gosh. So what, 1 today, 2 today. And then 1 tomorrow, 2 Saturday, 1 Sunday. Wow. Okay, let's have someone read the problem. You guys quiet. I'm gonna have Cam. Can you read the problem? Similarity applications.
In the diagram below, a large flagpole stands outside of the office building. Marquise realizes that when he looks up from the ground, 60 meters away from the flagpole, the top of the flagpole and the top of the building line up. If the flagpole is 35 meters tall, and Marquise is 170 meters from the building, how tall is he?
So what I would do, recognize that you have right triangles. Also recognize you have similar triangles. The flagpole, I'm pretty sure I would specify this, forms a right angle with the ground. We would expect that. Buildings usually, unless it's going to collapse or the Leaning Tower of Pisa, whatever, is going to form a right angle with the ground, right? And both the big and small share that angle right there, that little sharp corner off to the left. So if I set it up, 35 over 60 equals, before you leave, Connor, hold on a sec. Let me give you the packet. Okay. So be very careful here because that 170 was the whole thing. What if this was 170 from the flagpole to the building, not to the person to the building? Then what would I put over here then? Not 170, but 230. If the 170 was from the flagpole to the building, but the 170 was clearly from Marquise to the building. So good luck to you. So be very mindful about that. And then cross multiply, work it out. I don't have a calculator with me, but if I were to.
5,000.
Okay. And then divide by 60. Actually, I have the answer in front of me. Yeah, you got it. Good work. I was going to cross cancel, but you know what? I like what you did. Just use your calculator. Don't get cute. And by the way, units. We do penalize for not putting units. So make sure you get used to putting units. Okay. All right. Kind of make sense? We're okay with that? All right. I will do the next one also, but then I'm gonna have you try the next couple word problems from your table groups. Okay. So let's take a look at the next one here. Okay, so let's have someone read. William, can you read the next one about the boat?
Similar triangles to find unanchored. Having this boat has come untied and floated away on place. She is sitting atop the cliff that is 35 feet above the water in the lake. If she stands 10 feet from the edge of the cliff, she can visually align the top of the cliff with the water at the back of her boat. Her eye level is 5.5 feet above the ground. Approximately how far out from the cliff is Tattered this boat?
Okay, there's an assumption here. This is why people don't like word problems. I know, I get it. Because you don't know what to assume. And this actually word problem is actually kind of terrible because you have to be told that the cliff where you're standing and the water are parallel. That's not usually true in real life. There's going to be a little bit of a angle there, but they're parallel. If that's true, then what do I know about this angle and this angle? They're congruent, and they're both right angles when you look at the person and the cliff to the water, right? So yeah, you got two right triangles again. They're similar. You got this guy and this guy. Two right triangles, 5.5 and 10. 35 and X. And work it out. So once you have the information and you know what to do with it, and you make a connection like, oh yeah, they're parallel. Oh yeah, I remember doing that. The corresponding angles. Oh yeah, they're similar. Oh, okay, now there's side of force. Oh, okay, then I set it up, right? Everything falls into place once you know the relationship, right? And the information, right? You know what to do with it. 5.5x equals 350. Use a calculator course. You should get 63.64 feet. And do be mindful how we ask it around. I know the instructions didn't say here, but we will be very clear on our test. Usually like 2 decimal places. That's typically our standard, but we'll specify. We're very careful about that.
Wait. Oh, wait. I thought X was like from the diagonal.
X. No. X was the base. Yeah. We didn't care about the diagonal line. That didn't do anything for us. Do you want to know how far the boat is from the cliff? Okay, go and try the next one on your own or in table groups. I'll pause, I'll freeze my screen and work it out. Very, no pun intended, but similar to the other questions. No, you got it. Those similar triangles. If we're doing similar triangles, it's probably similar to the other problems. Okay, I'll stop. All right. It's okay, never mind.
Oh, I'm
Don't joke.
trying to get it, but I don't.
Because the concept of similar triangles and problems are similar. The problem's the same as the other problem. Because we're talking about similarity.
Oh,
See, now you get it. Okay, good. All right, good. I won you over. Good. I was a little worried. All right. Okay. I'll work it out too. We'll share in about 2 minutes. Oh, by the way, watch out for the units, guys.
that just seems such a precision.
Do you want it?
No. Hey, guys, convert to centimeters. You don't need scientific notation. Because the height was given centimeters, but the ground distance was given in meters. Meters multiplied by hundreds.
Okay.
So guys, 1 meter is 100 centimeters.
It's not.
Centi means 100. Sure.
Oh, centimeters and meters.
Yeah, that's kind of sneaky.
It'll-
Yeah, I would strongly recommend you do that. Okay, guys, keep working. Lucas, let's focus. You too, Peter. Okay, tell me what you guys get for X after you solve it. Oh, by the way, this is the assumption we had to make. My apologies.
How's that one short?
Those are the same angle because of reflection. Because you're looking at the shadows, right? Yeah. Yeah, we had to assume that those two things are the same because of reflection. Because you look at the person's shadow or to look at the mirror, that angle of reflection is the same as the flagpole. So you have to assume the same angle between those two. And that's centimeters.
How is like the big one shorter than the shorter one?
Wait, which sides? A and C or B?
Like, how is this one shorter than that one?
Just don't go based off looks. I know, just don't.
Okay.
It's not the scale. Yeah, don't go based off looks. All right. Go and try the next one on your own again. Maggie. Oh, so it doesn't matter. It's up to you. Either way, it's fine. Yeah, if you did 157 over X, then you need 200 over 600. Yeah, just make sure you compare corresponding. It doesn't matter. It's totally up to you. Like if you compare sides within the same triangle, a small side to big side, then do small side to big side for the other triangle. It doesn't matter. Pull up to you. Yeah, sorry if that was confusing. So, okay, let's move on to the next one about Tarzan. And then we got some conceptual stuff. Then we got to do proofs. Then I'm going to talk about a test. So try this one on your own. Set up.
Where'd you go?
By the way, those are the same, right? Also keep in mind, you got it. Good work. You're fast. Yeah, think of it like this, guys. ABC, EDC, and also the fact that angle ACB and ECD are the same. So again, you have AA similarity going on here. AB is what we want to find, it looks like. Yes, that's X. BC, of course, is 28. DC is 10. D is 14. X over 28. Sure, yeah, totally, 100%. Hmm? Yeah, it's a little tricky. They say that so you have to read carefully. So they say that then he walks an additional 10 paces. So think of it like this. So starts here, right?
Yeah.
Goes 28 paces here. Sorry, send me back. You look at the tree, the point directly across where he marks spot then. So he marks he walks 28 this way. Or turning perpendicular to the river. And walking until Lonsac.
Will be Wolfram's like reaction.
Oh, then he walks an additional 10 pace for it. That'll be more clear. Yeah, walks an additional 10. Yes, I got it now. Does 28, then does this, then does 14. Yeah, that's a little vague. We'll make sure it's clear.
Like on Tin Hat.
Yeah, it'll be more clear.
Never understand TSPM.
Like how it was. What we I thought.
I think the previous one was fine. Oh,
He walks A to C.
hold on. No. He marks a spot and then walks 20 paces to point C from B. From B to C walks 28.
He marks. It says.
A tree at point A. So Tarzan's right here, put that way. That's why it's confusing. Point A was kind of somewhat, well, it wasn't totally relevant, but
And the width is from A to B.
correct. That's what, 392? So X has to be 39.2. And that's what, paces. 39.2 paces. But you're not gonna really walk across the river, so anyway. Remember, you have yourself vertical angles here. Okay, all's good?
Yes.
Okay. All right, so now the last few problems on this page, before we turn to the last page of the notes. I want you guys to figure out how to write the similarity statements. This is important too. How do we write these similarity statements? And let me double check. I think our test will have something kind of like this, so actually guys have to practice. Yeah. Yeah, for their expect, yeah. This is good. This is good practice problem. Okie dokie. So ABC, EDC. Yes, good. Good. Yes. Excellent. Yeah, because A goes with E. Whoa, that was loud. That's all right. Okay. So A goes with E. And apparently C is shared. So B's got to go with D. Okay, keep going. Try the other ones. A and E are the same. And you got yourself vertical angles too. Okay. Yeah. So A goes with E again, right? Yep. D goes with B, and C are the same. Thanks. A again. I know a lot of letters. Okay, for number 4, there's no number 3, obviously. Let me break it off like this. There's no number 3. It's got to be EDC because A goes with E. Because you're told they're the same. You're told that. Let's see here. Yeah, so you know A goes with D. Because you know how to position the second triangle. B goes with A. And C goes with E. That's how you know. You know how to position it. So that's going to be B. So now I know. ABC goes with what, guys? DBC. Sorry, say again. ABC goes to what? BDC. Yeah, because A goes to B, B goes to D, and C are the same. So that has to be triangle BDC. And that's by side. Okay, lastly, just the colon. Okay, can you stop playing the Play-Doh? I know it helps, but you need to focus. It's just distracting. Thanks. Yeah, so the colon means ratio, just so you know. So BC over CE equals AC over CD. Obviously you have vertical angles again from previously. So if I draw it, here's ABC. If I rotate things around, it should look like this. It'll line up like this. That's D, E, and C.
Is ECD.
Hold on a sec. Yeah, you got it. Good work. Correct. So BC and EC line up. And AC and DC line up. And they share the angle here. So this is yes, good work. Yes. Good job, everybody. So BCA same as ECD. Yep. So you want to line it up correctly. And that's going to be SAS similarity. All right, last page. We got a couple proofs here to do. Okay. For number 11, we kind of just toss that one in there. So it's like a screenshot looks like. Okay, by now you guys know that there's gonna be a ratio, right? You have something on the left side, something on the right side. You gotta compare it correctly. So we want to compare the corresponding sides. Yes, right. Yeah. We want to compare those corresponding sides correctly. So if I break off that the little triangle that's up top, 11.
And then,
That's just a part of the proof. Yeah. Ignore what's below this line here. Ignore that. So, and actually, let me erase this. So we'll call this 3x minus 3. Three x plus 7. So see what I just did? I looked at the little triangle up top. The big one, 3x plus 7 and x plus 14, combined it all, and then set it up. How can I set up my ratio? What can I say? What over what?
We can say basically 3x minus 3
Over.
Well,
Sure. How about the other guy? Correct. Only thing that's kind of
Where'd the 10 fall to?
because you combine these two to get the big side on the left side. To get the left side of the big triangle. Okay. The one thing that's a little crappy about this problem, and we won't do this to you guys on a test, not quite like this, but we will expect you guys to do a quadratic, is they have a quadratic. Meaning we're gonna have to do some factoring. But we care about this as someone who's taught algebra 2 for almost every year for the last 21 years of the school.
what's the quadratic?
I'll show you in a moment. we kind of want you to practice the skill because it comes, you guys did it often in middle school and it's common in algebra too. So we have x squared and we have to do factor in a quad form.
I know what that is.
So if I cross multiply 3x minus 3, x plus 14, well,
No, you thought that was funny.
I'm gonna have you guys solve it, work it out. Just gonna check your algebra skills, see how it's going. If you guys get stuck, let me know. We'll see how it goes. Then we'll do some proofs after this. Hopefully getting this so far. 3x squared plus 39x.
Minus 42.
Yeah, good. Bingo. Equals 36x plus 84. Yeah. Move everything to one side. You should get this.
Wait, how'd you get 3 on 30 subtract? Oh.
Careful the arithmetic, right? And I factor out the 3. Yeah, that problem's a little intense. It'll be not as intense on our test, but it's a good problem. Now, which one are you gonna go with? -7 or 6?
6.
Yeah, you can't have a negative side. It's impossible. So it's gotta be 6. Yeah, good. Oh, so I had a question. Sorry, I had a question. Oh, we'll check. We'll check. Okay. By the way, you also could have done this too. You could have said, just off to the side here, 3x minus 3 over. I'm gonna give us a little shortcut. It's not a big shortcut, but that would have worked also. What I did in black off to the left. If you compare the two sides are broken up, you can actually do that. It saves a little bit of time, but you could have done that too, just so you know. Okay, ready for the proof? All right, last one. I know it's been a pretty long lesson today, but the good news is that we can use all of next week for review. So that's good. And one thing I might do to help you guys, I might try to make myself available on Wednesday evening before the test on Zoom. If you guys have any burning questions Wednesday night, I've done that with other students in the past, so I might do that if you think you'll find it helpful. Let's go look at my calendar to make sure I can do that. So yeah, it's like dropping off. So like you're studying at night. Yeah. All right. Here's what we'll do. I'm gonna again. Good. That's a good. That's a good start. I like it. And we know this is always given. We know what you're trying to prove is got to be your last step. Okay. So I'll do some red for the. Oh, I'll tell you some other things that are going to happen here too. We're going to definitely want to say vertical angle is congruent. We're probably going to want to say that angle ABE congruent to angle DCE. We're also probably want to say this as well. Okay. So what am I going to put under statement 1? Good, Ollie?
180.
Correct. Thank you. And where are my vertical angles here? Good, Ollie again?
Angle A. C. E.
Correct. ABE is congruent to DCE. I know my handwriting sucks. I'm sorry. No, thanks. All right. So AV to DEC.
Oh, C.
Same thing. Tomato, tomato. Yeah, and let me make that more neat. My apologies. No, ABE is a different angle than AEB. That's going to be what? Go ahead, Ollie, again. Yeah. Yeah, alternate angles congruent. So old stuff. But you do want to make it complete for parallel lines. Because you have to, make that reference to parallel lines. Yep. And then, right, the triangles are similar. So you could say, however you want to say it. If I say it's ABE, have to line it up. It's similar to triangle CDE. Yep. Wait. Yeah, ABC.
Would be any angle.
Yeah, correct. ABC. Sorry. ABE to DCE. Yes. And lastly, if they're proportional, you can say corresponding sides of similar triangles are proportional. That's like an acronym, CSSTP. Or some, I don't know what you want to call it, but yeah, corresponding sides of similar triangles are proportional. Okay. We can forego the challenge. I think you guys have done well. We could probably look at it next week. The test. Let me talk about the test briefly. So we're looking at probably 9 questions on the test. I do have the outline. I'm going to share this with you guys in just a moment. So these are a list of topics. I'll put the electronic copy in Schoology. So if you click on these, there's a hyperlinks. It'll take you to the CPM textbook to look at the problems, or you can just look them up yourself. But do we want to identify corresponding parts and figures? Absolutely. Do we want ratios? Yes, we do. Do we want to solve equations? Yes. Do we want to determine how they're similar? Yes. Proofs? Yes. Stretching? We did it a while ago. We're going to have to review that next week. Pythagorean theorem and similar ratios, geometric mean? Yes. Word problems? Yes. Pythagorean theorem? Yes. Distance? Yes. We haven't talked. That's been a while since we did that. I don't know if we're really I'm gonna put a little question mark here. I'm not sure if we're doing that. I'll give you some clarity next week. I don't think we are. Writing equations for multiple representations of linear functions. I'm not sure we're doing that either. But this one, you should know, this will be a part of a problem.
What is that?
Multiply binomials like this. Just what we did in the previous problem.
Oh, factor.
It's not factoring. It's doing the opposite. FOIL, yep. Built into a similar triangle problem. But everything else, pretty much fair game. The problems are here. I'm gonna give you guys a package in just a moment. You guys want to get a head start. There's 8 pages of problems. The answers are included as well. So we will work on this in class on Monday, but if you have it complete over the weekend, yeah, that's awesome. We could talk about it. I'll still produce more materials on Monday, and also gonna do a Delta Math with you guys as well. Wednesday, what I'm probably thinking, not Wednesday, sorry, Tuesday, what I'm probably thinking is put problems on the walls or the boards and I'll kind of talk about stuff. So yeah. And the retake is today during Y period. If you're in AC, go to AC, come here. So, all right, let me hand out the review packet.
Use it. No.
You don't have to.
What is it?
The start producing the test next week. I know the retake is obviously on the
Wait, is
forefront right
it-
now.
Is it on Thursday?
Yeah, Thursday next week. Yeah.
Is, let me